Hi, in this video we're going to use trigonometry to find a unknown side of a right angled triangle. We're going to use something called Sohcahtoa, which I'm sure you've seen already, but you might be unsure of how to use it. Hopefully these examples will help. We're going to look to start with at naming the sides of a right angled triangle. This is key to using trigonometry with right angled triangles. Once you've mastered that, it's literally a case of putting your numbers into your calculator and pressing the buttons and answers coming out. But without the first part, you're going to struggle to know what to do. We're going to calculate some unknown sides of right angled triangles, and at the end I'll give you some revision notes as ever to form a collection for your own use. So let's start off by labelling this right angled triangle. The bottom left hand corner, you'll see we've got our right angle just here, and opposite the right angle, so wherever your right angle is, on the opposite side, this is always the longest side of your right angled triangle, and it's given this name. It's called the hypotenuse. Hypotenuse. Okay, so the hypotenuse. This is going to be important. We're normally going to shorten this to either HYP or just simply H. Okay, now the other two sides are called opposite and adjacent, and they're opposite or adjacent to the angle. So we need to know an angle. I'll put an angle down here, and we'll just on this one just call it 25 degrees. Okay, so opposite this angle. Well, opposite the angle is on the opposite side, over here. And we'll call this the opposite, OPP, or just O. And the final angle is adjacent to, the final side, sorry, is adjacent to the angle. So that's going to be next to. Adjacent means next to. So here we go, this is my adjacent, or we can just call it ADJ, or simply A. So we've got these three key letters, H, O, and A. Okay, now let's see if we can work from there to see if we can work out some relationships between the sides of them. Okay, so let's start looking in a little bit more detail then about how we can use the names of the sides of the triangle that we've got. Let's just label up our right angle here, and let's just say that this is 30 degrees here. So opposite our right angle was our hypotenuse, opposite the 30-degree angle is called opposite, and the last one is A. Now, from Sohcahtoa, we can see that S is next to the letters O and H. This means sine. The S stands for the word sine, or the trigonometric ratio, sine. All it means is that sine of a given angle, in this case 30 degrees, is equal to opposite over the hypotenuse. Now, whatever the value of O is, and whatever the value of H is in a right angled triangle, if you do opposite divided by the hypotenuse for a 30-degree triangle, you're going to get the same answer. Okay, so sine of 30 is the same as whatever opposite side and whatever your hypotenuse side is divided. So opposite over hypotenuse is the same as sine 30, and that information is stored in your calculator ready to go. Sine of 30 degrees is already in there, and it's a number. Okay, so sine 30 is just going to give you a number. It'll always be the same number, and it lives in your calculator. So let's have a look. S-O-H, sine. Sine is opposite over hypotenuse. Okay, let's see if we can do the same with the next bunch of letters then. Next we've got Ka, so Soh-Ka. That has an A and an H in it, and this stands for cos, or cosine 30 degrees equals, can you guess? Adjacent over hypotenuse. Again, the adjacent is the side over here. Here's your adjacent, here's your hypotenuse. The triangle that we're going to draw out is going to look like this. Cos is adjacent over hypotenuse. And finally, we've got an O and an A next to the T, and T stands for tan. So tan 30 degrees. Again, cos 30, that's just a number that lives in your calculator, as is tan 30. Tan 30, I'm hoping you've already written down, is opposite over adjacent. And again, using a triangle, we can say TOA. This is where our Sohcahtoa comes from. It's just a mnemonic to try and help you remember which order and which trig ratio we're going to use given some information. So depending on what we've been given, we're either going to use sine, cos or tan over that angle. Okay, let's do an example and see. Here is a right angle triangle. I'm going to label it up again. Let's give some information. Let's say that we know that the hypotenuse is 10 centimeters. Let's say we know that the angle of this triangle, let's go with 30 degrees again. Doesn't really make any difference, but 30 degrees is quite a nice one. And I'll also say that what we're trying to find out is this side over here. Okay, so the first thing we need to be thinking about is, well, what information have I got? Well, I know the name of this side. It's the longest side of my triangle. This is my hypotenuse. So I've got an H. Where X is opposite the angle. So I'm going to call that O. Now thinking back to my Sohcahtoa, which one has O and H in it? Well, S-O-H, has the O and the H in. So let's fill in the missing parts as to what we know. Let's write in all the bits that we have and let's see what we're left with. Well, we know that sine of the angle, so sine 30, equals opposite over the hypotenuse. So sine 30 equals x over 10. Now, using the triangle above, if you cover over the part that you're trying to find, we're trying to find the opposite. So if you cover over opposite, then you will be able to see. So I'm not actually going to cover it over, I'm actually going to rub mine out so you can see what's left. But we've got sine and hypotenuse. Now, you'll have used triangles like this before. When you've done speed, distance, times triangles, it means sine multiplied by hypotenuse. Or if you prefer to do it algebraically, then the 10 that was divided over here, we need to move it up to the other side. So we're multiplying both sides by 10. We end up with 10 multiplied by sine 30 equals x. I do this bit on my calculator. 10 multiplied by sine 30, and I will get an answer of 5. If you don't get 5, you need to double check that your calculator is in degrees mode. Have a look at the little bit of information, maybe reset your calculator, look at the display, look at the top line. You're looking for a D in a box or the word deg. So if you don't get 5, in this case it'd be 5 centimeters. If you get a funny answer, check that you're in degrees. Okay, let's have a look at another example. In this triangle, you'll see, again, I'm going to give you some information. Let's say that we've got a length down here of 20 centimeters. Let's say I've got an angle. Again, I'm just using 30 degrees, but it doesn't make any difference. Let's say I've got X up here. Here's my right angle. Let's think about what information we've been given and what we know. Well, to start with, I'm going to start thinking about labeling up my triangle. Opposite the right angle, or the longest side, is called our hypotenuse, so we've got an H. Okay, we've got nothing opposite the angle this time. There's no information there at all. And we've not been asked to find it either, but we have got something here which is next to the angle or adjacent to the angle. So we've got an A and an H. Thinking about our Sohcahtoa again, Sohcahtoa. Which one's got the A and the H in it? Well, it's this one, cos. So we're going to say cos 30 degrees is equal to the adjacent divided by the hypotenuse, which is the same as, so cos 30 equals, now adjacent in this case is 20, the hypotenuse is the thing we're trying to find. We're not quite sure what the hypotenuse is. We can use our triangle again to help us. CAH. I'm trying to find the hypotenuse, so I'd normally cover that over with my finger, or in this case I'm just going to rub it out. We can see now that we've got the adjacent divided by cos. Similarly, if you prefer to, you can swap these two over. Okay, so you multiply both sides by x, divide both sides by cos 30. Either way you think about it, you end up with x equals cos 30 divided by, you end up with 20 divided by cos 30, and that gives you an answer. And again, I'm just typing this into my calculator, 23.09, and again it's centimetres. As a quick check, I know that the longest side of my right angle triangle is the hypotenuse. I'm trying to find the longest side. I'm just checking that this answer I've got, 23.09, is bigger than the information I was given to start with, and it is. So as a double check, I would always do that. Okay, let's do a final one. This time we're going to use tan. It shouldn't come as a huge surprise. Let's just label up and let's just see why we're using tan. So here we've got x. I'm going to say that this is 6 meters, and let's say this is 42 degrees, just for a change. Okay. Here's my right angle. I've got nothing on the hypotenuse this side, nothing at all. I have got information over here and next to my angle. Remember, opposite my angle and next to my angle, or adjacent to the angle. So this time I'm using the O and the A. I'm using the toa part of Sohcahtoa, so I can say that tan 42 equals opposite over adjacent, opposite over adjacent. Tan 42 equals, well, opposite in this case is x, and the adjacent is 6. Let's do the small triangle again, TOA. I'm trying to find this time the opposite, so if I remove that, I can see I'm left with T multiplied by A. So I have tan 42 multiplied by 6. Actually, do you know, I'm going to delete this and I'm going to write it slightly differently, and you'll see, I'll explain why. If I do 6 multiplied by tan 42 equals x. The reason for doing this is just so that your calculator doesn't do tan of 42 times 6. 42 times 6 is going to give you an answer of 252. I don't want to do tan of 252. I want to do 6 multiplied by whatever tan 42 is in my calculator. It might seem like a small difference, but it makes a massive difference sometimes to the answers here. So we have to be really careful when we're using our calculator. Stick the number at the front and then use your trig ratio at the end. So 6 times tan 42. That's going to give me an answer of 5.40 meters, just at 2 decimal places. There's not a huge amount I can check this time, other than to think, well, 42 degrees. If it was 45 degrees, I'd expect my opposite and my adjacent to be the same size. So the same size length, because a 45, 45, 90 triangle is an isosceles triangle. This is a little bit smaller than the other side, and it's a slightly smaller angle than 45 degrees. So again, that kind of makes sense.